Hello everybody, thank you for coming to the Senior Design Show. We worked with Safran on a flow screen for a jet engine test cell.
My name is Braxton.
My name is Richard Wolf.
I'm Gage Wolf.
Jim McCoy.
Our problem statement was to regulate airflow to gather more accurate testing measurements. But why does this matter anyway? Safran is the world's second largest airplane parts manufacturer, which means that they have a lot of customers around the world. For both civilian and military use, it's necessary that these new and improved jet engines that they're creating and will create, we're able to take accurate measurements so that nobody gets harmed in the process.
The project requirements given to us by our sponsor were four majority ones. There was the velocity distortion index across our flow screen, the pressure drop between our flow screen, the size, and then the flow velocity.
So the macro simulation shows the whole wind tunnel and the wind going through it, along with the turning vanes, entrance, and flow screen. The main components of it are the VDI and pressure drop. The VDI shows how the velocity of the wind is distorted through it and how it becomes more uniform as it goes through the turning vanes and the flow screen. The pressure drop shows how the pressure changes as well through the wind tunnel.
And here's a simulation of the flow plate itself. You can see before the plate, the air is much more turbulent, a lot more jumbled up air, mixed up air, and then after the air goes through the plate, it becomes much more streamlined, represented by a much more elongated streamlines, representing laminar flow and much more smooth air after the plate.
One of the pieces that we had to look at for this project was structural analysis. In order to test this, we took a 1,000 Pascal pressure drop across a 1 meter by 1 meter plate with our final design on it. When we did this, we were able to tell how much the plate deflected and if the plate would break during use.
To do our cost estimate, we needed to create a bill of materials, which is identifying what the different components of our design are. And there's three, which is the flow screen itself, the structural support, and then the bolts that we use to attach the two. To do the cost estimate of the flow screen, I'm going to be doing it based off of the meters squared of the area of the flow screen. I'm going to be using the foot length used per the beams for the structural support, and I'll be doing the cost estimate for the bolts per bolt used.
Thank you all so much for coming to the design show, and I hope that you enjoyed our presentation.